Introduction. It is standard practice in the design and planning of dwelling units to permit the electrician to plan the circuits. Thus, the resistance plans do not customarily include layouts for the various branch circuits. The electrician may follow the general guidelines established by the architect. However, any wiring systems designed and installed by the electrician must conform to the NEC, as well as local and state code requirements. This chapter focuses on lighting branch circuits, the circuits supplying the electric range, oven, clothes, dryer, and other specific circuitry not considered to be a lightning branch circuit or a small appliance branch circuit are covered later in this text. Refer to the index for the specific circuit being examined. Some branch circuits in dwellings are required to be rated not smaller than 125% of the load on the branch circuit. The requirements ensure the conductors and overcurrent device are adequate to carry the load without overheating. Examples are electric water heaters, central electric space heating, and air conditioning equipment. Voltage. All calculations throughout this text use voltage values of 120 volts and 240 volts. This complies with the requirements of NEC 220, which lists the various voltage values to use for different electrical systems. This is repeated in the second paragraph of Annex B of the NEC. The word nominal means in name only, not a fact. For example, in our calculation, we use 120 volts, even though the actual voltage might be 110, 115, 117, and even 123 volts. This provides us with a uniformity in making load calculations. Most public service commissions required that the voltage for residential services be held to plus 5% of the nominal voltage as measured as the service point. Calculating loads. When wiring a house, it is all but impossible to know which appliances, lighting, heating, and other loads will be turned on at the same time. Different families led different lifestyles. There is tremendous diversity. There is a big difference between connected load and calculated load. Generally speaking, a calculated load is the load as determined by the values that are required by the NEC for branch circuits, feeders, and the service. A connected load is the actual load of the luminaire, appliance or equipment that is connected to the electrical system. Who knows what will be plugged into a wall receptacle now or in the future? It's a guess at best. Over the years, the NEC has developed procedures for calculating loads in typical 1 and 2 family homes. The rules for doing the calculations are found in NEC Article 220 for lighting and general use receptacles. The calculations are based on volts, amperes per square foot. For the small appliance circuits in kitchens and dining rooms, as well as for the 2-wire laundry branch circuit. The basis is 1500 volt amperes per circuit. For large appliances such as dryers, electric ranges, ovens, cooktops, water heaters, air conditioners, heat pumps, and so on, which are not all used continuously or at the same time. There are demand factors to be used in the calculations. Following the requirements in the NEC, the various calculations roll together in steps that result in the proper sizing of branch circuits, feeders, and service equipment. As you work your way through this text, examples are provided for just about every kind and type of load found in a typical residence. Inch, pounds versus metrics when calculating loads. As discussed in Chapter 1, converting inch-pounds measurements to metric measurements and vice versa results in odd fractional results. Adding to this problem, the values are rounded off when the NEC code-making panels convert the measurements to metric. When square feet are converted to square meters and the unit loads are calculated for each, the end results are different, close, but nevertheless different. To show both calculations will be confusing as well as space consuming. Many of the measurements in this text are shown in both inch-pound units and metric units. Load calculations throughout this text use inch-pound values only, which aligns with the examples given in Annex D of the 223 NEC. Calculating floor area. The general lighting load for a dwelling is based on the square footage of the dwelling. While there are several ways to accomplish this, we will use a simple draw rectangles method. For the first floor, we will use a large rectangle for the gross area and subtract unusable and outdoor areas. For the basement, we will draw a smaller rectangle for the largest continuous space and add additional spaces to it. First floor area. Note in the residence plans that the first floor area has an irregular shape. For this floor, we will consider the outside dimensions of the dwelling as one large rectangle. Then the areas of the following spaces will be subtracted from the total area. Open porches are unfinished spaces not adaptable for future use as a habitable room or occupied space. Many open porches, terrace, patios, and similar areas are commonly used as recreation and entertainment areas. Entertainment areas. Adequate lighting and receptacle outlets should be provided for these areas. For practicality, the author has chosen to round up dimensions for the determination of total square footage and to round down dimensions for those areas, porch and portions of the end at the front of the house, not to be included in the calculations of the general lighting load. This produces a slightly larger result as opposed to one of the conservative side. Don't be miserly with your time with your measurements. Rather be generous. Figure 3-4 shows the procedure for calculating the total square footage of the first floor of this residence. Basement area. The NEC in 220 tells us that unused or unfinished spaces not adaptable for future use as a habitable room do not have to be included in calculating the square footage of a dwelling. Most basements in homes today could be considered as being adaptable for use as a habitable or occupable room in the future. However, crawl spaces in most attics would not normally be considered as being adaptable as habitable rooms or occupiable spaces. This is a judgment call based on a close examination of the plans and the specifications. In this residence, more than half of the total basement area is finished off as a recreation room, which certainly is considered a living area. The workshop area also is intended to be used. However, it is not considered as a habitable room, but would qualify as an occupiable space. To simplify the calculations for this basement, we will again draw rectangles but use an additional method. A rectangle that represents the largest continuous space is drawn and smaller rectangles are added to it. The floor area of the garage is only the first floor. Combined area. The calculated floor area of the dwelling is found by adding the floor area of the first floor and basement areas together. The determination of the first floor area using the subtraction method and the area of the basement using the additional method is shown in the following table. Determining the minimum number of lighting branch circuits. Section 220 of the NEC tells us that the minimum unit load requirement for dwelling units is 3 volt amperes per square feet, 33 volts amperes of floor area. Important requirements for calculating the minimum lighting load for dwelling units are found in NEC 220. This calculation includes general use receptacle outlets and some small motors. No additional load is required for the outlets on these branch circuits. This section reads 220 dwelling units minimum unit load. In one family, two family, and multi-family dwellings, the minimum unit load shall be not less than 3 volt amperes, 33 volt amperes. Unit loads include the following lighting and receptacle outlets, and no additional load calculation shall be required. All general use receptacle outlets of 20 ampere rating or less, including receptacles connected to the circuit specified in 210, bathroom branch circuits, and garage branch circuits. The receptacle outlets specified in 210, outdoor receptacle outlets, and G receptacle outlets in basements, garages, and accessory buildings. The lighting outlets specified in 210. The minimum lighting load shall be determined using the minimum unit load in the floor area as determined in 220.5 for dwelling occupancies. Motors rated less than 1 HP and connected to a lighting circuit shall be considered part of the minimum lighting load. The floor area of the dwelling unit as determined in 220.5 times the unit load and then divided by the ampere rating of the branch circuits is used to determine the number of branch outlets required. Additional branch circuits are required for small appliances, laundry, appliances, and so forth. To determine the minimum number of 15 ampere branch circuits required for general purpose lighting and receptacles in a residence, here are the simple steps. This equates to a minimum of one 15 ampere lighting branch circuit for every 600 feet. Let's calculate the general lighting load for the dwelling that is used in this book that has a total area of 355.56 feet. Because we cannot fraction of a branch circuit, we round it up to a minimum of 6 15 ampere lighting branch circuits. We get the same answer using 600 feet for each 15 ampere lighting branch circuit as follows. No matter which method we use, a minimum of 6 15 ampere lighting branches circuits is required. In informative Annex D of the NEC, we find many examples of load calculations. Here we also find that except from the calculation result, a major fraction of an ampere 0.5 or larger, such fractions are permitted to be dropped. That is based on 220.5, which states that the fractions of an ampere smaller than 0.5A are permitted to be dropped. Author's tip. This permission is for load calculations such as step 1. This permission to draw fractions is not to be used in step 2 because it is impossible to have fraction of a branch circuit. That is why we rounded up from 5.9 to arrive at a minimum of 6 ampere branch circuits. Load calculations for small appliances, branch circuits, and other major appliances branch circuits are in addition to the general lighting loads. These calculations are discussed throughout this text as they appear. The NEC in 210 states that the calculated load shall be evenly proportioned among multi-outlet branch circuits within the panel boards. This is also encouraged as a minimal design practice, as the neutral conductor size is based the amount of unbalanced load in the system. The less unbalance between the undergrounded conductors, the less current the neutral conductor will need to carry. Table 3-1 is the schedule of the 15 ampere lighting and 20 ampere branch circuits in this residence. NEC 210 states that a branch circuit is rated according to the rating or setting of the overcurrent device. For example, a lighting branch circuit supplied by a 15 ampere combination of AFCI type circuit breaker is rated 15 amperes, even if 12 AWG copper conductors with an ampacity of 20 amperes are installed. Small conductor overcurrent protection. The NEC also tells us what the maximum size overcurrent protection device that is allowed to protect certain size conductors for general applications. This is referred to as the small conductor rule and can be found in 240.4D. For small conductors, the rules for maximum overcurrent protection are as follows. How many outlets per circuit? This is covered in detail in Chapter 8, where you will find estimated loads for outlets, how many outlets per circuit, circuit loading rules of thumb, and the 80% rule. Track lighting loads. Track lighting loads are considered to be part of the general lighting load for residential installations, based on 3 volt amperes per square foot as previously discussed. There is no need to add more wattage volt amperes to the load calculations for track lighting in homes. As required by 410, the connected load on a lighting track is not permitted to exceed the rating of the track. Also, be sure that a lighting track is supplied by a branch circuit having a rating not more than that of the track. There is more information on track lighting in chapters 12 and 13 of this text. Summary of where receptacle and lighting outlets must be installed in residences. The following is a recap of the NEC requirements for receptacle and lighting outlets. We will look at these code rules room by room later in this text. Remember the NEC provides minimum requirements. There is nothing wrong with installing more receptacles than the NEC minimum. You will never have enough receptacles. Think about it. Receptacles are needed for just about every aspect of our lives, from charging cell phones to plugging in our laptop computers, as we need power in just about every square inch of a home. Consider spacing receptacles closer than the minimum. Consider quadplex receptacles or 2 duplex receptacles at each receptacle outlet location. And consider surge suppression receptacles or surge protection multiple plug-in strips. See Chapter 6 for a discussion of surge protection. Author's tip: some electricians install a receptacle below the wall switch in bedrooms, living rooms, family rooms, and similar rooms. As is usually the case, the required receptacles will be behind furniture, making it difficult to reach for plugging in a vacuum cleaner or other temporarily used appliance. A receptacle below the wall switch will be very easy to get to, a real plus. See Figure 3-2 for an explanation of receptacle and receptacle outlet. Receptacle outlets: 125 volts, single phase, 15 and 20 amperes. Group fault circuit interpreter, GFCI protection is required at specific locations in a home. A receptacle outlet where one or more receptacles will be installed. A receptacle outlet with a single receptacle, one contact device. A receptacle outlet with a multiple duplex receptacle. This is 2 receptacles, 2 contact devices. A receptacle outlet with 2 multiple duplex receptacles. This is 4 receptacles, 4 contact devices. A receptacle outlet box and 3 arrangement for receptacles. Arc fault circuit interpreter. Protection is required in specific locations in a home. AFCI are discussed in Chapter 6. Receptacle definition. The NEC Article 100 defines the following: receptacle, a contact device installed at the outlet for the connection of an attachment plug or for the direct connection of electrical utilization equipment designed to mate with the corresponding contact device. Single receptacle. A single receptacle is a single contact device with no other contact device on the same yoke or strap. Multiple receptacle. A multiple receptacle is two or more contact devices on the same yoke or strap. General requirements for receptacle outlets. Receptacle outlets that are rated 125 volt, 15 and 20 amperes are required to be installed in accordance with the general requirements specified in 210.52 through A4. These requirements apply to dwelling units in the following rooms or areas: kitchen, family room, dining room, living room, parlor, library, den, sunroom, bedroom, recreation room, or similar room or area. The following is a partial list of code requirements for receptacles are required in new homes or when a home is remodeled. Receptacles are located throughout a home for the convenience of plugging things in. The location for receptacles required by 210.52A through A-4 are the mandatory minimum requirements. Any receptacles that are wall switch controlled, part of a luminaire or appliance, located inside of a cabinet, are located more than 5.5 feet above the floor, are in addition to the minimum requirements and do not count towards those required by 210. However, a duplex receptacle that has one receptacle switched and one receptacle hot continuously meets the receptacle requirements of 210 and the switch requirements 21070. Wall receptacles must be placed so that no point measured horizontally along the floor line and any wall space is more than 6 feet from a receptacle outlet. Wall space. As shown in this section, a wall space includes the following: any space 2 feet or more in width, including space measured around corners and unbroken along the floor line by doorways and similar openings, fireplaces, stationary appliances, and fixed cabinets that do not have countertops or similar work surfaces. The space occupied by fixed panels and exterior walls, excluding sliding panels. The space afforded by fixed room dividers, such as freestanding bar-type counters or railings. Receptacle outlets located in the floor are more than 18 inches from the wall are not to be counted as meeting the required number of wall receptacle outlets. An example of this would be a floor receptacle installed under a dining room table for plugging in warming trays, coffee pots, and similar appliances. Hallways 10 feet or longer in homes must have at least one receptacle outlet. See Chapter 10 in this book for additional discussion about this requirement. Foyers that have an area that is greater than 60 feet are required to have a receptacle located in each wall space as defined in 210. See Chapter 11 in this book for additional discussions about this requirement. Circuits supplying wall receptacle outlets for lighting loads are generally 15 ampere circuits, but are permitted by the code to be 20 amperes. Receptacles for servicing HVAC equipment, 210.63. This is discussed in detail later in this chapter. Receptacles are required to be installed on the outside of the home as well. Outdoor receptacles are generally required to be GFCI protected. These requirements are covered in detail in Chapter 6 of this text. All non-locking receptacles rated 125 volts through 250 volts that are located in damp locations are required to be listed as weather-resistant type. All receptacles rated 15 and 20 ampere, 125 volts through 250 volts, non-locking type that are located in wet locations are required to be listed as weather resistant type. All receptacles rated 15 and 20 ampere, 120 volts through 250 volts, non-locking type are required to be listed as tamper resistant type. At least one receptacle outlet is required in each vehicle bay of attached garages and detached garages with electrical power. See Chapter 16 in this book for additional discussion on this requirement. A receptacle outlet is also required for each accessory building that has electric power. Basements. In finished basements, the required number, spacing, and location of receptacles, lighting outlets, and switches are required to be conformance with 210.52 and 210.70. GFCI protection for receptacles is required unless the receptacles are for a fire or burglar alarm system. Receptacles within 6 feet from the top and side edge of the bowl of the sink are required to be GFCI protected. There are no exceptions to this requirement. Receptacles in areas with sinks and permanent provisions for food preparation, beverage preparation, or cooking must also be GFCI protected. Unfinished basements or unfinished portions of basements that are not generally lived in, such as work areas and storage areas, are not subject to the spacing requirements or receptacles as specified in 210.52. In each separate unfinished basement area that is not intended to be lived in, such as storage areas or work areas, at least one 125-volt single-phase 15 or 20 ampere receptacle must be installed. 210. This receptacle must be GFCI protected. This includes receptacles that are an integral part of porcelain or plastic pull chain or key lead lamp holders. Small appliance receptacle branch circuits. See Chapter 12 in this book for discussion on the branch circuit and receptacle requirements for kitchens. Requirements for GFCI and AFCI protection are covered in Chapter 6. Laundry area. See Chapter 15 in this book for comprehensive discussions about the requirements for receptacle outlets and branch circuits in laundry rooms or areas. Bathroom branch circuits. See Chapter 12 in this book for a discussion on the branch circuit and receptacle requirements for bathrooms. Requirements for GFCI and AFCI protection are covered in Chapter 6. Outdoors. At least one receptacle is required to be installed on the front and another in the back of one-family dwellings, in each unit, two-family dwellings. These receptacles must be readily accessible from grade level and not more than 6.5 feet above grade. See Figure 3-3. Each unit of a multifamily dwelling where the entrance egress is a grade level must have at least one receptacle outlet meeting the requirements of 210. Grade level could be grass, sidewalk, or driveway. It is possible that a concrete or brick patio might be built at grade level. In addition to the front and back receptacle requirement, let's take a look at receptacle requirements for balconies, decks, and porches. Balconies, decks, and porches. We don't want people running extension cords throughout doors or windows openings, pinching the cord. We find these requirements for balconies, decks, and porches that are attached to the dwelling unit and are accessible from the inside of the dwelling. At least one receptacle outlet is required that is accessible from the balcony, deck, or porch. The receptacle outlet must not be more than 6.5 feet above the walking surface of the balcony, deck, or porch. Additional receptacles may be installed higher, such as receptacles used for plugging in ice and snow melting heating cables and or decorative outdoor lighting. For servicing HVAC equipment, 210 requires that a 125-volt single-phase 15- or 20-ampere rated receptacle be installed as follows. Be at an accessible location, be on the same level as the HVAC equipment, be within 25 feet of the HVAC equipment, not be connected to the load side of the equipment disconnecting means. E- Evaporative coolers are exempt from the above requirements. Why are evaporative coolers, often referred to as swamp coolers, exempt? Because they do not contain anywhere near as many complicated internal parts as a typical air conditioner or heat pump. There is less need for maintenance on this type of equipment, less expensive than an air conditioner or a heat pump. They contain one motor that pumps water to the top of the unit. The water falls downward over porous filter pads where the water is cooled by evaporation. A second motor fan pulls in outside air and blows the air over the cooled water into the room. Evaporative coolers work great in hot, dry climates. The higher the humidity, the less efficient is an evaporative cooler. Outdoor receptacles required by 210.521, one in front, one in the back, might or might not meet the requirements of 210.63. If the HVAC equipment is located on a roof, in an attic, or in a crawl space, or in a similar location, a receptacle must be installed in that location so as to be on the same level as the equipment. Ground fault protection and equipment GFPE must be provided for fixed outdoor dishing and snow melting equipment. GFPE can be a circuit breaker or a receptacle, or maybe self-contained in the equipment. Don't confuse GFPE with GFCI protection for personal GFPE devices. For equipment protection, typical trip at approximately 30 milliamperes of leaking current. However, the specific trip setting of GFPE needed must be specified by the manufacturer. Receptacles and other locations. All of the required receptacles discussed previously are in addition to any receptacles that are part of luminaires or appliances, are located inside cabinets, or are located more than 5.5 feet above the floor. Specific loads. Appliances such as electric ranges, ovens, air conditioners, electric heat pumps, water heaters, and similar loads are discussed later in this text. See the index for their location. Receptacle and branch circuit ratings. Table 3-2 shows the requirements of 210 and Table 210.21, where the branch circuit supplies two or more receptacles or outlets in homes. The table also points out that where the branch circuit supplies a single receptacle, the receptacle must have a rating not less than the ampere rating of the branch circuit. Lighting outlets. The NEC contains minimum requirements for providing lighting in controlled dwellings. Switch lighting outlets. Per 210.70, lighting outlets in dwellings must be installed as shown in Figure 3-4. Here is a summary of these requirements. Habitable rooms. In every habitable room, laundry area and kitchen, and in every bathroom at least. One lighting outlet that is controlled by a listed wall-mounted control device must be installed. The term listed wall-mounted control device includes the traditional line voltage switches and dimmers, as well as the newer technology switches that operate by radio signal. The wall-mounted control device must be located near an entrance to the room on a wall. This requirement applies to habitable rooms, kitchens, laundry areas, and bathrooms. Switch receptacles meet the intended of this requirement except in kitchens, laundry areas, and bathrooms. At times, ceilings luminaires are omitted in bedrooms, living rooms, and similar rooms. Instead, the room lighting is dependent on cord and plug connected table, floor, wall, and or swag lamps. The definition of habitable room in NEC Article 100 is a room in the building for living, sleeping, eating, or cooking, for excluding bathrooms, toilet rooms, closets, hallways, storage, or utility spaces in similar areas. As illustrated in Figure 3-5, swag lamps are not hardwired. They are connected by weaving the cord throughout the chain. Wiring split-wired receptacles is the key to providing convenient control of cord and plug connected lighting. These switch receptacles generally should be controlled by ordinary snap switches. Be aware that NEC 404.14F requires that general use dimmer switches and electronic control switches, such as timing switches and occupancy sensors, shall be used only to control permanently connected loads, such as incandescent luminaires, unless listed for the control of other loads and installed accordingly. The required minimum spacing or receptacle is found in 210.52, already discussed in this chapter. When laying out and roughing in the wiring for split wire receptacles, remember that the always hot portion of a split wire receptacle qualifies for the required receptacle. The switch portion of a split wire receptacle is not considered to be one of the required receptacles, but rather is considered to be in addition. If plug-in swag lighting, as illustrated in Figure 3-5, is used in a dining room, a switch receptacle connected to a general lighting branch circuit must be installed. In other words, you still must install the receptacle supplied by the required 20 ampere small appliance branch circuits. Where do I learn more about split wired receptacles? In this residence, split wire receptacles are used in the living room and the bedrooms. The wiring of split wire receptacles is covered in chapter 2, 3, 8, 12, 13, 14 of this text and is shown on blueprint sheet 9. Additional locations. At least one lighting outlet must be installed in hallways, stairways, detached garages, and accessory buildings with electrical power. These lighting outlets are required to be controlled by a listed wall-mounted control device. The NEC does not require that a detached garage or accessory building to have electric power, but if it does have electric power, then it must have at least one GFCI receptacle, and it must have one or more lighting outlets controlled by a listed wall-mounted control device. At least one lighting outlet must be installed to provide illumination on the exterior side of outdoor entrances or exits that has grade level access to dwelling units, attached garages, and detached garages if they have electric power. A sliding glass door is considered to be an outdoor entrance. These lighting outlets are required to have a listed wall-mounted control device. A vehicle door in a garage is not considered to be an outdoor entrance. Stairways. At least one lighting outlet controlled by a listed wall-mounted control device must be installed to provide illumination for stairways. If there are 6 stair risers or more on the interior stairway, requires that a wall-mounted control device must be provided on each floor level and any landing level that has an entryway. This switching requirement involves permanent stairways to basements and attics, but does not include fold-down storage ladders commonly installed for access to residential attics. The International Residential Code is more specific about stairway lighting. It requires indoor stairways that have lighting that will illuminate the landings and the treads, and that the lighting shall be located in the immediate vicinity of each landing at the top and bottom of the stairs. This code also requires that the switching must be accessible at the top and bottom of the stairway without using any step to reach a switch. If you don't install a listed wall mounted control device, what else is acceptable? Remote control, central control, motion sensors, photo cells, and other automatic devices may be installed instead of a listed wall-mounted control device for the control of lighting in hallways, stairways, and at outdoor entrances. For example, an outdoor post light controlled by a photo cell does not require a separate switch. Attics and underfloor spaces, utility rooms, and basements. At least one lighting outlet must be installed in spaces that are used for storage, con- con- contain equipment that requires servicing, such as attics, underfloor spaces, utility rooms, and basements. These lighting outlets must be controlled by a wall switch or a listed wall mounted control device. A point of control is required to be located at each entry that permits access to these spaces. Examples of equipment that may need servicing are furnaces, air conditioners, heat pumps, sump pumps, and so on. The lighting outlet must be at or near the equipment that may require servicing. Also, keep in mind that if the lighting outlet is in a crawl space, that it is at or below grade level. GFCI protection for lighting outlets not exceeding 120 volts. Common areas in two-family or multifamily dwellings. NEC 210.25 contains specific requirements for circuits that serve a common area of two-family or multifamily dwellings. Be careful when wiring a two-family or multifamily dwelling. For areas such as a common entrance, common basement, or common laundry area, the branch circuits for lighting, central fire, smoke, security alarms, communication system, or any other electrical requirements that serve the common area are not permitted to be served by circuits from any individual dwelling unit's power service. Common areas will require separate circuits, associated panels, and metering equipment. The reason for this requirement is that power could be lost in one occupant's electrical system, resulting in no lights or alarms for the other tenants using the common shared area. For example, a two-family dwelling would probably have two separate stairways to the basement. If only one stairway is provided to serve the basement of a two-family dwelling, then lighting would have to be provided and served from a branch circuit originating from each tenant's electrical system so that each tenant will have control of the lighting. For a common entrance, two luminaires will be installed and connected to each tenant's electrical system. Likewise, fire smoke security system in a two-family dwelling are normally installed and connected to branch circuits originating from each tenant's electrical panel. This becomes an architectural design issue. This is not generally a problem in two-family dwellings, but can become a problem in dwellings having more than two tenants. The design of the common areas for the two-family structure that is shown in Figure 3.7 will normally require an individual meter and service to supply the common area branch circuits. A fourplex would probably require a 5 watt-hour meter, 4 watt-hour meter for the tenant, and 1 watt-hour meter to serve common area lighting and the fire smoke security systems.